Oh, hi, it's Adam Creek here, and this is my submission on task 3.1p using the iSorter interface for the sort-k method to implement my three sorting algorithms: bubble sort, selection sort, and insertion sort. I'm going to run through fairly quickly to keep the video a lot shorter than my previous one. So I'll start by showing you the result from the tester file, and all the tests actually pass. And so regardless of the class, the algorithm class that I've been asked to develop, or the default, and the criteria, all the tasks pass as required. I'll focus on now bubble sort using the debugger tool. Get that one off, turn that on. Start the debugger. Okay, so we can see here I've declared my class here as per the instructions. I have a local variable count that's set to the length, and if we walk through that, we can see now that count is now actually set to the integer of 20. I have an outer loop where we're using the local variable of I, set that initially at 0 on the condition that it is less than the total count, in this case is 20. An inner loop where the comparison happens and the index swap, if required, happens, and that is using a local variable of j, and that is on the condition that j is less than count minus 1, which is 19, so 0 to 19, which is 20. If we walk through to the main code that compares using the default compare function, so we're comparing the index j, which in the vector, which is 333 value, to j plus 1, which is 236, and applying the logical test, is that greater than 0? If it is greater than 0, do the index swap. So if we jump into that, have a look, we actually then call the compare function. We're comparing 333 against 236. We're obviously returning 97. Skip through that return. Greater than 0, we will then swap the indexes. And we can then check now the sequence to see that 236 now has an index of 0 and 333 has an index of 1. We jump through this again. The next test will be compare test will be between 333 of an index of 1 and 312 of an index of 2. Obviously not in ascending order. So let's jump through that, jump into it. 333, 312, 21 is the return, and that clearly is greater than 0. So it's going to then swap the indexes, and we can double check if that's actually occurred. And yes, it has. 312 is now index 1 and 333 is index 2. So we can see now that the vector is now being sorted progressively, and as we iterate over the remainder of the numbers, what will happen is the smaller numbers compared will actually then start to bubble up to their respective position within the vector, and the result will be a sorted vector according to the input criteria. So the other two, which I'm not going to go through in much detail, is selection sort. Selection sort, again, this one here we set a minimum value, we declare it, assign it to I in the outer loop here. We then use our compare, built-in compare, default compare function, compare the value that we're pulling in against that minimum value. We then will reset that as a minimum value and check if there's a smaller minimum value that actually has been found. Finally, I have insertion sort. Likewise, very similar sort of format and setup. Set a temporary variable in my outer loop, and in my inner loop I do the compare using the compare function, and compare that temporary against the value that I've put in. If it's the case, then I swap that and decrement the j value. So that will actually then reset that and effectively sets it at the smaller number. The result of this will be that once it iterates over the values, I'll get a sorted list. And that is my three sorting algorithms very quickly. Vector file is the same and tester file is the same. If you have any questions, feel free to ask. Thank you very much. Cheers.